Now that we have talked about how algebraic terms can be simplified, how they can be combined and put together, we are now going to manipulate them a little bit more, and we're going to talk about something called expanding algebraic expressions. So in this case, what we are going to generally do is we are going to multiply and distribute terms. Now, what do we mean by distribute? I want you to think about distributing as kind of like when you're handing something out, you want to make sure that you give things out evenly, for example, right? So in this case, we are going to do a quick example of what this would look like. Simply put, let's say I have 3 and it is multiplied by 4x plus 2. So I'm going to use the color blue here, and this is something I actually recommend you doing in your actual assignments as well, just so you remember what steps we're following. So here we could distribute where I am going to hand out, right, the 3 to the 4x and to the 2. So what I mean by handing out is I'm just going to multiply these numbers. And what you could do is you could do 3 times 4x, which then will be 12x plus 3 times 2, which is 6. Now, simply put, this is all that you need to know for expanding algebraic expressions. All right, I'm going to give you an example, though, of how this would work with normal numbers. So this is actually something that you could apply even with numbers that have no variables in them. So let's try to remodify this. If I have 3 times 4 plus 2. Now, according to PEMDAS, we know that this will be 3, and then you multiply it by, you got to do what's inside the brackets first, right? Or the parentheses. So 4 plus 2 is 6, and so 3 times 6 is 18. But let's try using the distribution method. So if I have 3 and then 4 plus 2, let's see if this could still apply and we get the same answer, right? So I'm going to distribute these numbers out here. So 3 times 4 is going to be 12 plus 3 times 2, which is going to be 6. And then if I add them together, I'll get 18. So this rule actually applies for the order of operations. And this can actually be an exception to PEMDAS, right? So you could actually do the multiplication without having to do what's in the parentheses as long as you remember the rule to distribute. It's absolutely necessary for algebraic terms because you can't add the letters together, right? You can't add terms with variables and constants or other variables. So now I want to add one more thing though, and this is combining some of the knowledge we have. So let's try what happens when we are expanding a negative number. We're going to say include the negative or the symbol, or let's say the integer sign, in your calculations. All right. So let's try to see what this looks like. Let's do an example here. So we'll do a sub. So let's do example. Now we're going to add negative 3. And then we have 4b minus 2. So, as we know, we are going to distribute by having the negative 3 multiplied into these two numbers. What I want to point out, though, is this negative 3, the negative or the minus sign kind of becomes an integer. Now, the 4b doesn't have any sign, so we could leave that as its own unit. But take a look at this negative or minus 2. Even though it's a minus 2, in this case, we're going to treat it as if it's a negative 2. So one thing to consider or keep in mind is that all these numbers are going to act kind of like integers at this point. So it's like, imagine that you're just putting a bunch of numbers side by side and you're trying to do multiplication to these numbers. So let's try this out. Negative 3 times 4b is negative 12b. Now, negative 3 times negative 2 is going to be, and here, I'm actually going to show you something here. If you're not too sure of the calculations and you want to do it on the side, I've recommended this in the past, and so I recommend doing it for this. Any side calculations you need to do, just do it over here. All right, so negative 3 times negative 2. I don't want to interfere it with the main calculation that I have, but I want to make sure I'm recording this. So I know that it's going to be positive 6. So I go back to the original equation here and I just put plus 6, and that is what I get here. So you see how it's as if I'm writing negative 12b and positive 6, but now when I look at it again after all the parentheses are gone, I could treat it like it is negative 12b plus 6. All right. And so, for one more example, we are now going to try a slightly more complex question. And I'll do it on the side here, but you could just continue this below your activity or your notes. So let's do one final one, which is something complex. So let's do 4 and then times 3b plus 2 minus 3 times 2b plus 4. If you'd like to give this a shot first, you could go ahead and pause this video at this point, and then you could hit play again when you're ready. So before I continue, or as I start this, I do want to make sure that I identify all my terms. I got the 4 there, I got the 3b, I got the plus 2. Now on this side, I have a negative 3, I have a 2b, and I have a positive 4. So the 4 is going to be multiplied by the 3b and the 2. The negative 3 is going to be distributed to the 2b and the 4. So I would recommend doing something like this, because then you could just put all the numbers side by side letter. I think another way to look at it is you could imagine as if they are two separate sections. So don't worry about adding or subtracting anything like that right now. You just want to focus on doing the expanding. So let's say I have 4 times 3b, which I know is 12b, and 4 times 2, positive 2, is positive 8. Now, let me just write the rest of the question as is. I prefer doing this sometimes because then it allows me to know that I've worked on one side, right? And I could just focus on one thing at a time. So instead of trying to do it all at once, sometimes this might help. All right. So now I'm going to do the right side. Now it is going to be negative 3. And actually, I'll just do this again. Negative 3 times 2b and negative 3 times positive 4. So I'm going to start by just leaving some space in the front here. So I could put the equal sign. Actually, I could just write 12b plus 8. But let's try to do this other side. So now I have negative 3 times 2b, which is negative 6b, and negative 3 times 4, which is negative 12. There we go. Now, what I need to do here is simplify. So usually the question will say expand and simplify. Even if it doesn't say simplify, I think by default you'll just try to do it. And the best way to do this is by making sure that you have these terms all sorted next to each other. So I would start with the first one here, which is 12b, and I would just write that down first. Then I'll cross that off to remind myself that I already wrote that down. Now I want to look for all the b's, and I want to try to do it in order. It isn't going to change too much if you don't, but it's a good idea to continue doing things in order of left to right, because sometimes there are some order of operations that are sensitive to the left or right. All right, So now I have my like terms grouped together, and I will now do 12 minus 6b, which is 6b. And then I will have positive 8 minus 12, which is going to be negative 4 or minus 4. And that is my response there. So that right there is a quick overview of expanding algebraic expressions.